Hey, welcome back to ECE 382. Today we're going to move on to Module 5, Building the Robot. We're going to talk about the battery and voltage regulation and the power budget for our system. We're also going to talk about some of the physical components on the chassis board, which we're going to build in the lab next class. So we're going to have our robot built by the end of next class. But in this video, I'd like to talk about some of the different things that are on that chassis board and helping us to provide our power and signals for the embedded system of the TI-RSLK Max. So first off, looking at battery and voltage regulation. In an embedded system, power management is really important. You have to make sure that you can power all the different systems that are part of your overall embedded system. So in our TI-RSLK Max robot, that includes the motors, the distance sensors on the front, the LCD, the different sensors on the bottom, the line sensor, and that also includes the MSP432 itself. So the chassis board is going to help us to manage that power, but the key thing is this is not a power class, so a lot of these concepts we're not going to delve really deep into, and you'll see those in other classes like ECE 215 and some of the other power classes. But today we're just going to kind of get an idea of how power management plays and power budget plays a role in an embedded system. So looking at the power budget, really the goal is to figure out how long will the system run with the given battery life. Additionally, we need to ensure that each system, so all these different components, are getting the voltage that they need. So on the chassis board, there are two voltage regulators. So one is a 5 volt, it provides 5 volts, and the other provides 3.3 volts. And these regulators provide the constant voltage to the MSP432 and other components as well. It's important to note that there are constant voltages because those components require a constant voltage, but the current is variable depending on how much of a draw those components are pulling. So the MSP432 has a low power mode, which allows it to draw less current. So these regulators, it's 7 volts in to the regulator, and depending which one you need, it either be 3.3 volts out or 5 volts. So there's two different regulators, and we'll see those later. But that requires 6 AA batteries to get us 7.2 volts. So we can go greater than 7 volts, so we have 7.2 volts, and then our regulator is going to take those down to 3.3 and 5 volts. So then the nickel metal hydride batteries that are rechargeable, those are the ones I had you guys order. You will be able to recharge them whenever you want. If there's any issues or if some batteries die, I will have extras, so that will allow you guys to never have to wait on batteries charging. But they have 2300 milliamp hours. So let's just say, for example, we only had motors. We weren't running anything else, and our motors pulled, example, motors pulled 0.5 amps. Let's just say it's a constant 0.5 amps. Then our 2.3 amp hour batteries would last us, we'll drive the motors for about 4.6 hours. So there's a lot of other things driving or pulling on our battery. So MSP432, like I said, of the sensors. So we can imagine that our battery life is going to be much shorter than this. And you can see here in this diagram, the current draw is going to be different depending on, are we using the analog to digital converters? Is the CPU running? Are we using, is the ADC off and the CPU's on, etc., etc. Then we have a sleep mode. We won't go into a whole lot of details on how to use these different modes, but just know that there's different things we could do to extend our battery life if we needed to, and that kind of really allows us to then, drive and control our system for longer if we had that expectation or requirement. But in this class, it's not that important. So what we will do is we'll just use the batteries. You'll trade them in. I'll give you new ones if you need to, if you don't charge them every night. But hopefully you guys will charge them after you use them, and then we can just keep on rolling. Let's talk a little bit about the chassis board. So this is what the chassis board is. That's going to sit straight on the black chassis that is going to hold, the motors and everything along that. But the chassis board itself holds the MSP432 in these three male pin connectors here. So your MSP432 is going to sit on top of that, along with, switch over to yellow, along with, nope. Can I get something? Anyways, it's right there. Boom. Alright, so those pins as well. So you need to pay close attention to that pin right there so you don't bend it and break it. But the MSP432 is going to sit there. The board will provide power to the MSP432, and then will provide us all the pins to go to our different sensors. So, for example, this is our motors here. Our LCD will go here. A number of other things as well. And so that chassis board has internal wiring to our MSP432. So all of these different components can get and communicate with the MSP432. So the battery is going to connect. Obviously, we input the batteries underneath, and then there's you can see a few different battery pins coming out here. That's providing the power to the chassis board. And then right here is our latching on off. I recommend this to stay off, and then just use this button right here to turn on and off your your whole RSLK max. So this on off switch, just keep it off, use the button. Alright, we said there was a number of voltage regulators. There's two primary, so the 5 volt and the 3.3 volt regulators. The motor drivers, that's what's allowing us to pass a pulse width. So basically pulse width modulation signal, so just something along these lines is coming, and we'll learn a lot more about that from the MSP432. That goes to a driver, which then changes a signal however is needed by the motors. And that is that tiny little black chip there and there. And then our actual motors, this is what our motor pin looks like. That's going to connect right here and here on each side. And we'll see that when we build the actual robot in class next time. We do have an encoder built into each motor. So that allows us to determine how fast the wheels are spinning. We're going to use that information a lot to determine speed, turning rates, and things along those lines. There's some pins that we already, everything on the motor, on the robot has been built and pinned out for you already. Mr. Jacobs spent the last 2 weeks soldering pins here for the LCD, and then here. So these 3, and these 6 all go to our IR distance sensors. Okay, and then if you ever need to, so this is your robot, if you ever are using it in a different class or anything that you want to do as a side project, we do have power pins that you can access, 3.3 volts if you want to add on any other sensors or systems. Double check your MSP432 to make sure that the 5 volt pin is disconnected. So we are disconnecting that. That is an important thing to note. We are operating the MSP432. We want this 3.3 volt connection to be made. And what that allows us to do is switch between powering the MSP432 between batteries and that USB cable. So we can switch between those. So when we plug in our USB cable, we're actually powering the MSP432, and we can also power the MSP432 straight off the batteries. But with that 5 volts, if that was connected, it would start having some issues as soon as we plug in the USB. So we have to make sure those are off to the side. All right, so what's going on here? So like I said, we have the chassis board. So this is kind of a more of a graphical representation of the actual chassis image here. And so the MSP432 is communicating, sending signals, the chassis boards facilitating those signals getting to where they need to go. So we, like I said, we have the MSP432 and our batteries. Those are going to the chassis board, and then we're not going to use speakers. We will use LCD. We're not going to use microphone, but we will use the 3 IR sensors. We have our 2 DC motors, the tachometers that are on those motors, 6 bump switches, and then we also have, which is not listed here, we have the line sensors as well, and that is part of the kit, so those are included. And that is an 8 sensor array. That just, it's also an IR sensor, but this one is using the time, it's using the sensors to determine if there's a black or white line. All right, like I said, there's the IR distance sensors. Those are going to be plugged in 2 different places. So what's going to happen is we're going to plug in those sensors straight into here. So basically we have IR sensor that is going to these low pass filters. So this is an analog signal. And there's a built-in low pass filter on the board, which is really nice. That allows us to get a really nice clean signal before we convert it to digital. So that's going to then go into our analog to digital converter. And then that digital signal is going to go to the MSP432. Now it's digital here. This is a filtered, what happened there? Filtered analog. And Mr. Jacobs was nice enough to solder on pins for us, so now we can just use the wires that came with the IR sensors when we build it and then connect those accordingly. And we'll do that in one of the main labs later on. You'll learn a lot more about this graph here, but I want you to have kind of an idea of what's happening as we're building this. So that's it for this module, this module's video. Next time we're going to build that robot. There is a pre-lab for you to work through, just kind of going through a little bit of this, but mostly of things we've seen in the past, allow you to have a little bit more practice and preparation for that next GR coming up here in a few weeks. All right, we'll see you in class.